Welcome to the ISU IMSE Capstone Project video for Spring 2020. Our group is Grant Davis, myself, Maddie Lynch, Arian Opti, and Bailey Preibel. We're Group 11. We worked with a company that focused on making oil tankers and lube vans. The main aspects of the process that we focused on were the tank and chassis prep bays and the throughput issues that they were having within them. They had recently purchased a crane and wanted to know the best bay layout and production schedule to use with the crane setup. We'll start by covering the objective, then moving into the current state analysis, then our future state design, and then economic and stakeholder impacts.
The specific objective of our project is to increase the throughput of the tank and chassis prep bays by 10% from 2019 to 2021.
Now on to the CSA. Spaghetti diagrams were created in order to determine the amount of distance that were traveled per shift, which came out to around 2,500 feet per shift, or about half a mile, and this was just within the bay. And mostly they were traveling to get tools, and to combat this, we came up with enforcing the use of tool carts. Also created a tool list for new hires, which was about 36 tools for tank prep and about 15 tools for chassis. For work sampling, we determined the amount of value-added and non-value-added tasks that were going on by checking what each member was doing every 5 minutes, and the most frequent non-value-added task was waiting. Onto the time study, we determined a benchmark for the tank and chassis prep.
In the FSD portion of the project, our group looked at bay layout, workforce requirements, and delay reductions. Here you can see the current state of the bay layout. The most important thing to note here is that the tanks and chassis are shown with the green arrows to be moved to the center aisle in order for the mounting process. Here you can see in the new layout that the tanks and chassis are no longer brought out into the center aisle in order for them to be mounted because of the crane, which allows the tanks to be mounted directly onto the chassis in the prep bays. The old layout is shown on the left again and the new layout on the right, but this is zoomed in onto the prep bays. The biggest differences are noted in orange here. So the tank prep bay is now in the middle and the chassis are now backed up into their bays. This is so that the tanks can be mounted directly onto the chassis without needing to be reoriented. The next step of the FSD is to look at workforce requirements, and we did this through a simulation. There were 4 different scenarios analyzed, which estimated the annual production for that scenario. There was 10-day cycles that were assessed. The first scenario assessed was the current state with no custom units and the additional work of the tie-down, and this did not meet the target throughput of our objective. However, we looked at adding a floater who would assist in the tie-down process, and this did meet our target throughput. But we wanted to take it a step further and make our simulation more realistic by including custom units in our assessment. The custom units take longer than stock units, and so because of this, even with the floater helping with tie-down process, the target throughput was not met. We then looked at utilizing the floater in more than just the tie-down process. In this case, the floater would work on the tie-down process and also helping with the chassis. In this scenario, the target throughput was more than met, and so this was the simulation scenario that we decided was the best for our company. We found that 2019 experienced 6% more delays than the simulation would allow in order to meet the goal. In order to find those 6% of delays to eliminate, we looked at low-hanging fruit. We first found that utilizing rolling carts could eliminate unnecessary walking. Calling ahead for inspections could be a time-saving opportunity. Calling for Kubotas and trucks ahead of time will also allow for elimination of delays. And finally, keeping team members in the designated bays and not working elsewhere. This accumulated to 8.5%.
Our project costs include a one-time investment for the crane and lifts, which have already been purchased and accounts for the harness system needed for tank prep. In addition, the 2 evac systems used for each chassis prep will have to be moved, which will have a $10,000 additional cost as seen in the table on the left. Also included is the overhead cost of bringing in a new member to work in the area and their corresponding yearly cost to the company. Taking all the numbers into consideration, our ROI, which is our return on investment, gives us a payback period of 4 months. This project consists of various factors that benefit the stakeholders directly or indirectly. To be more specific, reducing the delays and improving throughput will increase their sale and order quantity for future clients.